Now we want to see, here's the big picture of how to find the slope of implicit functions. Remember in the previous video, I said, here's an implicit function that I gave you, and here's a slope. And I told you that we're going to figure out how to derive this derivative function. And here's kind of the steps. It looks like a lot, so let me kind of break this down. So you might be given an implicit function, and in the end, we need to get to this slope. These are the steps that you're going to take, and it looks like a lot, but I'm going to walk you through it very briefly, and you're going to practice throughout this unit, so don't worry if you don't get it the first time. Okay, but if you're given any implicit function, what you're going to first do is a implicit differentiation, a derivative for implicit functions. And then you're going to isolate your dy dx variable to get your slope function. Okay, so I'll walk you through this process fairly quickly, and we'll be able to slow down later throughout the unit. Okay, first of all, when we have an implicit function, to get the derivative function, we're going to first need to take the derivative. So what I'll do is I'm going to take d dx on both sides. So I'm taking the derivative. So let's just start with the right side. We know d dx of 12, that's a constant, is 0. That's pretty simple. Okay. Now on the left side, it's a little bit more tricky, but I just found the derivative of each one, right? The derivative of x squared is 2x, derivative of y squared is 2y, negative 6x is just negative 6, and 4y is 4. Okay. Now here's where it gets a little tricky, and what you need to do is anytime you take the derivative of something, you need to add a deep link. So you need to, you need to multiply by d blank over dx, okay? Because that's what we took the derivative of right there. So here's what I mean. We took the derivative of an x squared, right? So what we need to do is multiply this answer 2x by d, and what we took the derivative of was an x function, so it's going to be dx over dx. I know that's really weird, right? Okay, now let's look at this function. That's a y function, so I need to multiply this by d length, which is dy over dx. The next one, it's an x function, so I need to multiply by dx over dx. And this last one's a y function, so I need to multiply by dy over dx. Okay. Now, you might be wondering, what about this one, this 12? Well, there's no variable, it's just a constant, so it's just 0. So that makes sense. Okay, now next step. What is dx over dx? Isn't that just a 1? So this is just 1. dy dx. dx is just 1. And then that's dy dx. Okay? So that is the implicit differentiation. So the final step is just getting it into this dy dx form. And notice we have dy dx here and here. So what we're going to need to do is do some simplification, combine like terms, and then isolate the dy dx. Okay, so the next step, if that's step 1, implicit differentiation, the next one is isolate dy dx. Okay, so how we're going to do that? Let's start with this equation right here. Okay, we'll go back to my red pen. Okay, so I first am going to want to take everything that's not dy dx to the other side. So that 2x doesn't have a dy dx, and that negative 6 doesn't have a dy dx. So I'm going to subtract 2x and add 6. Subtract 2x, add 6. Okay, so you see that shows it right there. Okay, and then these terms we cancel out. So all we're left with is dy dx terms on the left and non-dy dx terms on the right. So now, look, dy dx, I have these in common. So let's factor them out. So that means I'm going to pull out a dy dx, and then I have left a 2y plus 4 inside. So now I have dy dx times this quantity of 2y plus 4. So how do I get dy dx by itself? I just need to divide both sides by 2y plus 4. And there you go. That's right here, right? And so we can actually leave it like that's fine, but I want to clean it up just a little bit. I noticed that all terms are even, so I can divide out a 2. So I factored out 2 here on both the top and the bottom. And now I was able to create a 1. And there you go, my final answer of my slope is right there, which is what I told you what the slope was before in the previous video.